Today we'll be talking about dehydrohalogenation of haloalkanes to make alkenes. Now there's two different products we could get based on the type of base we use, a non-bulky base or a bulky base. In terms of the non-bulky base, we could have something like ethoxide or something like hydroxide. In terms of the bulky base, we could use LDA, for example, and here I'll draw out the molecule. And this molecule is in the presence of lithium. I didn't draw that here. Another example of a bulky base would be tert butoxide, and there are more. Now, a hindered base is one where the carbon attached to our charge is substituted. For example, these two molecules. The top one is unhindered, while the bottom one is a hindered molecule. So if this carbon attached to our charge is a CH or a C, we're going to get a hindered base. However, if our haloalkane is small enough, we will get substitution. This is the case with a methyl bromide. We will do SN2 reaction with a hindered basic nucleophile to get a different molecule than we would expect. In terms of the mechanism, the leaving group and the hydrogen need to be anti to each other. Here, groups A and B are anti to each other. We can also rotate the molecule such that group A goes into the paper and group B comes out of the paper, and these groups will still be anti to each other. We're maintaining stereochemistry here, and the reaction can still occur if group A, for example, is a hydrogen. So here our base is ethoxide, and this is a non-hindered base, and it's going to want to form the Zaitsev product in the most stable alkene. We will have to rotate our molecule to get it in the correct configuration such that the bromine and the hydrogen are anti to each other, because currently they're on the same plane. Here we have our rotated molecule, and our groups, the leaving group and our hydrogen, will be anti to each other. And now our base can grab that hydrogen and do the reaction. Those electrons from the hydrogen are going to come down to form the alkene, and it's going to push off that leaving group. And here we have our alkene, the final product. And we lose stereochemistry at this carbon because it is now sp2. Pause now if you would like to try this on your own.